So in the coming decades, we're going to be living in a very different world where we all will need to and hopefully be able to afford driving electric vehicles. And so we are just going to see an immense expansion of the technology from what's still kind of in some sense of designer technology today in consumer electronics to really being what's under the hood basically in many of our or most of our transportation modes. The keys to our approach is we've tried to take what is a very complicated interface with multiple phases present in proportions we still don't really fully understand. And we've tried to distill the problem by looking at individual components, single phases of these interfaces as model systems that we can grow on the lithium metal and then immerse in an electrolyte environment and then study how they evolve. We know is already happening in batteries when we immerse lithium and add electrolyte and assemble the cell. We know that there are dynamic chemical changes that occur. Some of these phases are actually not as stable as we thought, but they will continue to react with the electrolyte. And that existence of reactivity or stability is very much dependent on the chemistry, which is what we've learned from this work.
It's a great experience with c.l.s, I think. Used X-ray photon electron spectroscopy to get the chemical details of the surface. So the one advantage for synchrotron X-ray is that XANES can detect the signals without bringing damage to the surface. Using XANES, we can actually detect different signals, the different depth information of the surface. So this is one advantage that we consider using synchrotron X-ray here.
And what our study tells us is that you have to be very careful when you create a kind of foreign material and you place it into an electrolyte. It may not stay the same as the material you thought you put down, but in fact it can react in unexpected ways, particularly when we have certain salts around. So this helps us understand that we need to examine these points very closely when we're proposing new material solutions.